Okay, so in the previous video we looked at integers and what happens in variables, and remember they are immutable types. We can't change them. That's why new instances are created every time we try and change an integer. It creates a new instance. So let's have a look how that pertains to lists. So if I get list 1, and I'm just going to put the values 1 and 2 as I did in the introduction into it, and check the ID of the list. List 1, there it is, and if I do list 2 is assign list 1, and now do the ID of list 2. It should come as no surprise, it's got the same number, and indeed if we have a look at list 2, it's also got the values 2 and 1, so that's great. But we still teach that these are independent lists, or so we're tempted to. If I now do list 2 is assign the value 3, 4, what happens? List 2 is indeed 3, 4, ID of list 2. It's a new ID now, so it's independent, and that's fine. It looks like it's just worked exactly the same as it has for integers, and indeed when we assign new lists, that's the way it works. But remember what we did before. Let's just go back and make list 2 the same as list 1. So they're both the same. Let's just check that. List 1, list 2, yeah, they're the same. ID of list 1 and the ID of list 2. Okay, so they are definitely the same lists. And then what we did is we did list 1 dot append, and then we appended maybe the value 3 to that. And we'll just check what happened to list 1, because obviously we've appended 3. Have a look what happened to list 2. Aha, the value 3 has appeared there. Let's just check the IDs again. So the ID of list 1 ends 04, it's the same as it was before, it's not changed. And the ID of list 2 is also 4, so that's not changed. So let's try and understand what's going on there. Okay, so what happened? We created list 1 and we assigned it the list with 1 and 2 in. So what did that do? It basically created a variable called list 1. What did the variable do? That referenced memory, and in memory location we stored the values 1 and the value 2 as our list, and the list points to there. We then did list 2 is assign the value of list 1. What did that do? That created another variable called list2, and that pointed it to the same location, and we saw that. So they were the same list. We then actually completely changed list2. So we said list2 is 3, 4. Now because it's a brand new list, we're not trying to change list2. We're just inventing a brand new list2. When we did that command, what happened? Well, basically it went and found some memory somewhere else, put a 3, 4 in it, and it moved list 2. Oh, missed it there. It moved list 2 and pointed to 3, 4. So again, they appeared as independent lists. So that was all fine. But then we did something slightly different. So remember where we were. We had 1 and 2 in memory, and list 1 pointed to there, and we then did list 2 is assigned list 1. So now list 2 pointed to the same location, but then we did list 1 dot append. Now this is altering list 1. I think we appended the value 3. This is altering list 1. So now when we come to alter list 1, it does not create a new list 1, 2, 3 and move the list over, because lists are mutable. So when we appended the value 3, it looked at list 1 and it put the value 3 on the end. And because list 2 was pointing to the same place, list 2 also altered. So that's why we've got to be really careful when we assign one list to another list, if we use methods that alter one list, they will also alter the other list. They are not true independent copies. If you want to copy one list and make a completely separate copy of it, you should go and investigate the copy function, because that will do that for you. Okay, thank you.